We will discuss differentiation by using logarithms. First, we have to think whenever we take the logarithms. Suppose a function of the time y equals to fx to the power gx means functions, its exponent is also another function. This is known as transcendental function. Transcendental function. So, when the function is of the form transcendental function, that means the function whose exponent is also another function. In this case, we shall take logarithm on both sides. So, for example, suppose y is equal to x to the power x. X is a variable, also x is also another variable. So, variable to the power variable. In this case, we shall take logarithm on both sides. So, taking logarithm on both sides. Taking logarithm on both sides. That is log y equals to log x to the power x. Taking logarithm on both sides, log y equals to log x to the power x. Then it becomes x log x, because when there is a logarithm, then exponent will becomes the to the base. So x log x. So log y equals to x log x. Then differentiate both sides with respect to x. WRT means with respect to x. Differentiating both sides with respect to x. The derivative of log y with respect to y by using chain rule into dy by dx equals to, right hand side is the product of two functions x and log x. So we have used the product rule. So, taking x as fixed, differentiate log x first, plus log x fixed, differentiate x with respect to x. Log y, derivative of log y with respect to y is 1 by y, and here dy by dx, that is equal to x, log x derivative 1 by x, plus log x, here x derivative is 1. This implies dy by dx equals to y into x into 1 by x cancel 1 plus log x. So dy by dx is equal to y into 1 plus log x. Then substitute the value of y here. Dy by dx equals to y means x to the power x. Instead of 1, we can write log e. For simplification, this is also correct answer. Log e plus log x. That is equals to x into log ex. It is easy to differentiate a function whose exponent is another function. In this case, we shall take logarithm on both sides. Suppose another example. Y equals to sine inverse x to the power 1 minus s square root over. Here sine inverse x is a function and its exponent is another function. So we cannot differentiate by chain rule. We have to take logarithm on both sides. So taking logarithm on both sides, taking logarithm on both sides, taking logarithm on both sides, log y equals to 1 minus s square root over into log sine inverse x. Then we have to differentiate. Differentiate with respect to x. Derivative of log y, first differentiate with respect to y by using chain rule. Again y with respect to x. The right hand side is always the product of two functions. So we have to use the product rules. First, keeping fixed log sine inverse x, we have to differentiate 1 minus s square root over. Here we have to use the chain rule because 1 minus x square root over cannot differentiate directly. So with respect to 1 minus x square, again 1 minus x square with respect to x, plus fix 1 minus x square root over. Differentiate log sine inverse x with respect to sine inverse x, because we have to use the chain rule here. Log x, instead of log x, here the function is log sine inverse x into sine inverse x with respect to x. Log y, differentiate of log y with respect to y is 1 by y into dy by dx. Right hand side is log sine inverse x plus 1 minus x square root over with respect to 1 minus x square, means derivative of root x with respect to x, that is 1 by 2 root x. Again derivative of 1 minus x square is equal to minus 2x plus 1 minus x square root over log x with respect to x is 1 by x, means 1 by sine inverse x. Again derivative of sine inverse x is 1 minus x square root over. Then dy by dx equals to y into log sine inverse x into, here 2 cancel, log sine inverse x into minus x by 1 minus x square root over, plus here 1 minus x square root over 1 minus x square root over cancel, 1 by sine inverse x. Then we have to substitute this value y as sine inverse x to the power 1 minus x square root over. The sine inverse x to the power 1 minus x square root over into 1 by sine inverse x minus x by 1 minus x square root over into log sine inverse x. This is the correct answer. Sometimes when the functions are multiplied together, more than 2 or 3 functions, we may take logarithm on both sides. For example, suppose y is of the form x minus 1 whole square 3x minus 1 root over by x to the power 7 6 minus 7s square to the power 3 by 2. In this case, we shall take logarithm on both sides because it is not easy to differentiate the function by the quotient rule. Divide rule you cannot use because numerator is product of two functions, denominator is also product of two functions. It is not easy to differentiate directly. So we have to use logarithm on both sides. So after simplification, then we will differentiate. So taking logarithm on both sides, log y equals to log of x minus 1 whole square 3x minus 1 root over by x to the power 7 6 minus 7s square to the power 3 by 2. Then we have to simplify the right hand sides. We know that log a by b is a log a minus log b. That is log of x minus 1 whole square into 3x minus 1 root over minus log of x to the power 7 into 6 minus 7s square to the power 3 by 2. Then log of a into b equals to log a plus log b. Log of x minus 1 whole square plus log of 3x minus 1 root over minus log x to the power 7 minus log 6 minus 7s square to the power 3 by 2. Then this power will 2 into log x minus 1 plus half log 3x minus 1 minus 7 log x minus 3 by 2 log 6 minus 7s square. Then we have to differentiate both sides. Differentiate both sides with respect to x. That is log y, derivative of log y with respect to y into dy by dx equals to 2 derivative of log x minus 1 with respect to x minus 1 into x minus 1 with respect to x plus half constant derivative of log 3x minus 1 with respect to 3x minus 1 into 3x minus 1 with respect to x by using chain rule. Minus 7 derivative of log x with respect to x minus 3 by 2 derivative of log 6 minus 7s square with respect to 6 minus 7s square into derivative of 6 minus 7s square with respect to x. Then we have to use the formula. Log y means 1 by y into dy by dx equals to 2 log x minus 1 with respect to x minus 1, that is 1 by x minus 1 into x minus 1 differentiate of x minus 1 with respect to x is 1 plus half 1 by 3x minus 1 into 3x minus 1, that is 3 minus 7 by x minus 3 by 2 1 by 6 minus 7s square into minus 14x. Then we have to multiply this y on the right hand side and substitute the value of y as this. Then we will get the correct answer. This is the case when more function either divide or multiplied together, you may take logarithm on both sides. Next, when the functions are if the function is this type, suppose the function is of the form y is equal to x to the power 1 by x plus sin x to the power x. Here one is a function x to the power 1x, another function is sin x to the power x. We cannot take logarithm directly because here is a addition. So you take p plus q, where p is x to the power 1 by x and q is sin x to the power x. Then you differentiate separately. Here you take logarithm log p equals to 1 by x log x, log q is x log sin x. Then you will get here dp by dx, and from here you will get dq by dx. Then dy by dx equals to dp by dx plus dq by dx. You cannot take logarithm simultaneously because here is a positive sign or negative sign. In case of positive or negative, we cannot take logarithm directly. First, we have to take as the function p and this function as q, and we will make differentiate separately p and q. Then we add together. It will be the right process. If you take logarithm difference directly, then it will be the correct answer, but the process is wrong. Next, if a function is of the form y equals to x to the power x to the power x, here x to the power x to the power x, you take logarithm first, log y equals to x to the power x log x. Here we cannot differentiate directly. We have, because here the function is x to the power x, variable to the power variable is another function. So we have to take logarithm on both sides again. That is log of log y equals to log of x to the power x into log x. This implies log of log y equals to log x to the power x plus log of log x, which is equal to x log x plus log of log x. X log x plus log of log x. Differentiate with respect to x. Derivative of log y with respect to log y into log y with respect to y, again derivative of y with respect to x. We have to use the product rule here because x and log x are multiplied together. Derivative of x is 1, keeping fixed log x plus x, derivative of log x is 1 by x plus derivative of log x with respect to log x, again derivative of log x with respect to x. Derivative of log y with respect to log y is 1 by log y. Again derivative of log y with respect to y is 1 by y into dy by dx, which is equal to log x plus 1 plus 1 by log x plus 1 by x into 1 by x, 1 by x. Then dy by dx equals to y into log y log x plus 1 by x log x. So you have to substitute the value of y and log y here. Y means x to the power x to the power x. Log y means x to the power x into log x. And log x plus 1 plus 1 by x log x. Yes, this is the correct answer. So we make 2 times logarithm, as on the first case if we take logarithm for only once, the right hand side is another function which is also x to the power x. So it is necessary to take logarithm on both sides again. So this is your exercise 7F and it is an important exercise. तो आपको डिटेल करिवो जदि डाउट थिबो पचारिवो.